to stop? Good. So, once upon a time, I had a surprising situation which allowed me to build a startup. So I gathered together some of my more technical friends that I thought might want to join me in this endeavor, and we started brainstorming some ideas as to some things that we could build. Some of them included things like a VR arcade, because a year ago VR was very exciting, and a blockchain for managing weed deliveries, and a few other silly ideas that went along with the current industry buzzwords. We ended up deciding on a system that would use machine learning to capture the knowledge that farmers had acquired over generations of growing these plants through visual information using some IoT devices. So this is going to be the story of how that went. Spoiler, not well. So my name's Eric. I currently work at Circle CI. I enjoy doing things other than programming sometimes. I have a background in DevOps and software engineering. I've been doing that for a while. So why did we decide to build Grownome? Like, what made this seem like a compelling plan? Well, according to the UN, over the next 30 years, we're going to see a significant change in where food can be grown and the imports and exports of each of these countries. You can see the red ones will have a more difficult time growing. The green ones will be a little bit easier to grow there. But what's going to be common with all of these is that the kinds of biomes that farmers were used to will have changed because of climate change. So kind of the central thesis of Grownome was that growing plants is hard, and it's going to get harder, or at least different, for everybody. And if we can capture that knowledge of how farmers in a wide variety of biomes accomplish this now, we can build some predictive models to help understand actions that they should take in the future in the new biomes that they are going to be experiencing. So I put together a team of a data scientist, a farmer who was also a mechanical engineer, and somebody who had done sales. And another kind of thing I wanted to accomplish with Grownome is I had seen a lot of teams that we were really resistant to hire junior engineers, and I thought, I feel like I could teach this. I've taught this to myself. I've mentored people before. It seems like I can teach make programmers out of people. That seems like a thing that we can do. It turns out that's a lot harder than it sounds. But we have lots of mistakes. So it should make for a great retrospective. Hopefully you can avoid some of mine. All of us were remote. So we started building our prototype. This was our first one. We had 3D printed it out and got our little Raspberry Pi Zero W in there. We'd attached some humidity and temperature sensors to this thing and had connected up with Balena to deploy Docker images that were binary diffed onto the device. And we had contact with our first customer who wanted to put it in their grow room and monitor it with us. And we did that. It actually worked reasonably well. It was ugly, it was cheap, it got the job done. It was probably the best business choices that we made. But we immediately decided to make some other mistakes. So as I had just finished up my previous position at Autodesk, and so I had about 4 months between that job and my next job. I was like, okay, I'm going to go make this into a real business that it can do business things while I'm gone. So I immediately started Googling how do you start a business? And I found a great laundry list of all the different things you need to do to make an LLC and why you'd want that over a corporation and all of these different details. It turned out that all of those things had nothing to do with the success of my business. Our first mistake was, without question, spending way too much money on things that didn't actually deliver value to the customers that we wanted to deliver. We found that a lot of the time doing these organizational things, filling out this paperwork and setting up those sorts of things, they feel like progress, but they really just result in Dilbert comic frames. So one thing that I found incredibly important, kind of reflecting on this, is the criticality of defining exactly what value means to you. You'll note in this definition that value is a term that is relative to an observer. You don't find value as an objective experience. It's not the same for everyone or every company or every group of people. So you have to make sure that whatever it is you choose, it's something that is measurable and can be a reproducible process that you and your team can use to establish whether or not the choices you're making are driving that. Often, this is a tool that will help you choose to do things that are not as much fun. Fortunately, so I really like math. Fortunately, math has some thoughts about how you measure things. Put simply, a metric, according to math, is that it's a thing that you can give 2 points in a space, and it will tell you that they have a non-zero difference if they aren't the same thing. If they are the same thing, they should have a zero difference. If you navigate backwards from one point back to your original point, you should get the same distance as if you went the other direction. And finally, the triangle inequality of any point in between 2 points should have a smaller distance than the total line. Now, kind of bringing this back into the context of well, that's very abstract. How is that useful for business? Making sure that your value, whatever you choose for your metric for value, is something that's meaningful, that's actually related to your business, and actually measures that distance, is incredibly important. I really like the visualization of a maze for thinking about this problem. There are many ways that you can go about solving a maze. You can go and you can solve it with a random walk, and just every turn you go and just make a random choice as to which direction you're going to go. You could go and follow the right-hand rule. You could do a breadth-first search. But all of these methods have a common aspect that they don't have any understanding of whether the choice they just made things better. This visualization is of a maze solver called A*. The critical insight that makes A* a better maze solver than just a random walk or a breadth-first search is the notion of a metric. Every time it chooses which direction it goes and measures its new position relative to the endpoint of your maze. If that new position is lower, it makes that choice, put simply. You want to be able to do this in your business, especially since the dimensionality of your business isn't merely 2. You have thousands of dimensions of choices that you could be making. So the complexity of making these decisions is much higher, and you'll have much less information than this maze solver gets to have. So back to our regularly scheduled programming of what's going on at Grownome. We had built our business. We finished up all the paperwork. We were very proud of that. We had got our device out to a farmer, and I had decided that I should probably go and ask some of the managers and mentors and stuff that I had had in my past, what their thoughts on the matter were. So I explained Grownome to him. He had actually been a farmer, in a past life, and he questioned whether this product actually added any value to the farmer. Was the farmer actually going to gain something from maintaining all of these little devices all throughout their fields, and is this just going to be a massive overhead? This was really hard to hear for me. I didn't actually hear it until after Grownome ended. I was really wrapped up in the Kool-aid to save the world, which I think is actually a really important thing to have. You need to have some Kool-aid so that when things are really hard and you're grinding out at 2 a.m, you're like, oh, I'm doing this for a reason. There's a story that I can associate with myself. So there's a balancing act that you need to get at there. Also, be aware that your friends want you to succeed. So if you go and ask them, like, oh, do you think my idea is plausible? They're going to say, yeah, of course your idea is plausible. We think you're great, which is very different than I actually heard your idea and I'm giving you an opinion. So if one of them is brave enough to tell you you're wrong, you should probably listen. A little more on Kool-aid. I see it as a trade-off between delusion and substance. Every culture I've ever worked in mixes it a little bit differently. Some cultures acknowledge that they have Kool-aid, some cultures don't. Some cultures are like, nah, we just are transparent, when in reality that is literally their Kool-aid. Whatever the case is, making sure that you think about it and reflect on it as to which decisions you'd like your Kool-aid to drive you to make, and making that intentionally, is far better than doing it on accident. Oh. Okay. A quote from Paul Graham that I stumbled over on Twitter after the end of startup school, which we ended up doing a little bit later, was that one of the biggest differences between reality and going to school was that at school you get rewarded for effort, and in reality you really don't. Like, your customers just care about the concrete value that you added. This wasn't something that really any of us had the opportunity to face in our lives, because we had been, kind of lower down in the business echelons of wherever it was that we worked, and that context kind of gets lost from, management down through tiers and tiers and tiers. So back at Grownome, we were looking for some direction, and one of the people that I had talked to had recommended this book to us, the Startup Owner's Manual. It told us that we needed to make some market hypotheses, and then we should use some experiments to verify that these were true or not. So we made some docs to do exactly that. And we came up with a whole smorgasbord of them. Don't worry, I won't read them all. But if you'd like to, they're on the slides. We started small. After looking at all of these, we thought, okay, well, if we give farmers metrics, they will have lower crop loss. This seemed like something that was really concrete. We could measure it. It was low cost for us to deliver that to our farmers. So we thought, okay, this is a pretty simple test. We can just add some alerts and to our data, because Initial State was the platform that we've been piping all of this data into. They have this nifty little button that lets it text you when you go up above a boundary. We're like, we'll just text ourselves and then text our customers, and everything will be fine, because we only had 2 or 3 at that point. So we did that. We started advertising it on our first version of our website. It was super MVP. Our results was utter apathy, which was strange to us. We didn't really understand why that had happened. Now, normally when you're doing a startup, this is a part where you would measure and go, oh, well, this didn't work. I should do something different now. But there's another option you have. The other option is to believe that your experiment wasn't good enough. That maybe if you had a higher fidelity experiment, maybe it would have worked. So that's exactly what we concluded. We had started using Google Analytics to measure who was coming to our website and kind of determine the search terms that they were coming to it from. And what we had started to see was that people who had searched the right things didn't stay very long. And this was strange to us. But what I kind of take from this is that your customers who are skeptical are really good at helping you understand whether your perception of their problem is reality or not. When you pitch something to them, especially if it's a tool to help them with their core competency, like an IoT device to help farmers measure if they're growing, they probably know a lot more about their problems than you do. If you can't communicate to them that it's going to offer more value for the same amount of work, then you probably don't understand why your customer would want your product, or you don't understand your customer's problem. All of this to say, you should have everybody in your business, including your engineers, go and actually talk to customers, actually try to sell your product to your customers, and you will become quickly aware of the disparity between your understanding of your customer's problem and the customer's perceptions of their problem. So at this point, we had 2 or 3 customers, and we were looking for some ways that we could grow a little bit better because our market hypothesis thing hadn't really driven us in a better direction. And it happened to be that at that time, Y Combinator was getting ready to do its summer batch, so they had a program called Startup School. Startup School was what they normally ran all of their Y Combinator startups through before they actually started their batch, and kind of gave them a lot of context as to wisdom from previous founders and those sorts of things. So we applied to it because this year they were going to be letting anybody who applied and they accepted into Startup School, regardless of whether they were applying for funding from Y Combinator. And they were going to give us a mentor of somebody who was actually in the field. So we thought that this would definitely save us if they found us promising. We were accepted into the part of the program with mentors, which made us really excited. In retrospect, this probably should have concerned us. I think it's general wisdom that if you find yourself seeking out a status symbol, you should ask yourself why. In this case, we were looking for a marker of accomplishment, somebody else to validate that we were doing the right things, even though we really weren't. And that status symbol was kind of a reflection of that desire. No program or school or book or person or mentor will ever save you from your own perceptions and beliefs. You have to embrace the fundamental truths of whatever it is that you're trying to solve. In this case, you need a metric was the one that we hadn't quite gotten to yet. That being said, they did have us set up a metric, which was monthly recurring revenue. So one of the other things that we got to do with Startup School, which was really interesting, was meet our competitors. The way that Startup School operated was they had one mentor and about 10 companies. Each company sent a representative to go to a Google Hangout once a week, and then everybody did a stand-up together, and you kind of got to hear about what was going on with everybody else, and you did a little bit of talking about the presentation that had been given that week at Startup School. We met our competitors, and they felt much more threatening than they actually were, which taught us a lot about competitors. Something about our brains, or at least my brain, seems to make us want to pick up sticks and defend ourselves against the other guys, or people, or humans, animals, I guess. This isn't a super functional pattern. Your competitors probably aren't going to kill you yet. In our case, we were worried that they would absorb the whole market, which, since it was such a new market, there was no way they could conceivably have done that in the short period of time that we were interacting with them. It wasn't a problem yet. Maybe in 5 years it would have been. We worried that they would take our ideas. And once actually that did happen, and it worked just as poorly for them as it did for us. We worried that their product would be better. Maybe it was, but neither of our websites are up anymore. So, indulging in a scarcity mindset is incredibly dangerous, but it's really easy. It gives you a mission. It makes you feel like you're doing something. You're defending yourself from these other people who might take your business. In reality, there are plenty of people who need their problems solved, and if you just listen to them, they'll tell you. Upon finding this interesting interaction that we had with our competitors and the ways that this kind of formed our mindsets towards the rest of the market, it became really clear to me that it was really important to understand how each of my team members and each of Grownome responded to these external pressures. This extends beyond just your competitors. It also extends to different views that you have with your co-founders, conflicts of beliefs. because the relationship that you have with your co-founders is absolutely critical. These are the only other people who will benefit from your business thriving. The failure modes of these relationships, especially early in a startup, are more or less catastrophic for the business. So you need to embrace that there is going to be conflict. And remember that while it's painful, most of the time pain motivates change. Often that change is unplanned and not optimal. Aspire to change on purpose. As grim as it sounds, I observed that most people don't make significant changes to the way that they interact with hard things, whether it's something that they don't want to work on or a hard bug or something they've been hacking on for months, without some amount of pain. Our brains optimize for the minimum perceived energy cost. So take these opportunities when you disagree and when there's something intense that's going on with your co-founders to make changes that are positive for your business and the people inside of it, as well as your customers. So at this point, we had decided that we needed to rewrite a bit of our backend for a few reasons. One of our SaaS services had become 10 times more expensive than it was originally. Initial state used to be $300 a year, and we were going to get the bill for next month, and it looked like it was going to be $300 for the next month. So it was time to do some re-architecting. And we had also got our customers up to 4, and one of them had even asked for a more immersive interface. Originally, we had used a Firebase app that simply ferried data from Google PubSub into initial state, as well as keeping track of a link to each of these initial state dashboards for each one of our customers. We transitioned this all to a Google App Engine app, which was backed by a Postgres database that we used to store all of the metrics and metadata about the images that we had pushed up into Google Cloud Storage. All of the consumption of this data from Google PubSub was done using Google Cloud Functions, which were all written in Clojure script. We used Clojure spec to kind of validate all this data, and we'll get a little more in that. And then we had Google BigQuery for doing kind of our ETL flavored things where we go back and label all of the images based on whether we had thought they had been watered based on changes in humidity over the next couple hours, because when you water a plant, the water comes back out of the plant. It doesn't actually keep it inside of it, more or less. So there's a humidity increase, and we could go and label back those images. And then we pushed those images with those labels into Google AutoML, which gave us a model that you could point your camera at a plant. It would be like, that plant is watered, or that plant is not watered. And actually, that worked really well. It turned out that farmers are really good at determining whether plants are watered or not. It's just programmers that are bad at it. So that was our overall architecture that we used. Now, all of these components I've actually open sourced, so if you want to go dig around in the Clojure script and see how we actually built all this up, you can go to github.com/Grownome. Feel free to take it and reuse it or sell it if you want. I don't know. On the device, we had a CLJS client that ran on a Raspberry Pi 0W, using a bunch of specific interoperable libraries that were designed for sensors that people often connected to Raspberry Pis. We didn't actually start with CLJS. We started with Java. It turned out, though, that Java doesn't play super well with 128 megabytes of shared RAM and putting some of that RAM in your graphics card. So we switched to Node.js, which was ironically more efficient, and then connected it up to Google MQTT through that. It turns out that encoding bytes in JavaScript is a very frustrating process. It works better when you use specs, though, to validate that each one of your transformations actually produce consistent data. One of our co-founders was super frustrated with this architecture. He was like, I cannot understand what's going on here. We have this whole mess of core async channels all over the place, and they thought, you know what, we're just using so much core async. Why not write this in Go? Which I thought was going to be an interesting experiment. So they did, and it turned out that it wasn't simpler when we rewrote in Go. It was equivalently complicated. We dug in, fixed up those core async bugs, got the library for MQTT fixed up a little bit, so it did a better job of doing the byte encoding. And we added some specs, which helped a lot. We also switched from using Line to Shadow CLJS, which is an excellent build tool if you haven't tried it out for Clojure script, that allows you to have super tight coupling with NPM. In fact, it works so well that it ships with advanced optimizations on by default, including when you use node libraries from NPM. So that was an amazing experience. Props to that team. The Google Cloud JavaScript libraries, or the Google Cloud libraries, mostly have JavaScript equivalents for whatever reason. The Google Cloud functions only really allow you to use JavaScript right now, I think. They may have Python now as well. I saw they released Go, too. So when we were working on this, it was mostly just JavaScript, so we were restricted to those client libraries. So having tight integration with the NPM ecosystem was really non-negotiable. And there were externs that were actually embedded in each one of these projects, but the Clojure CLJS compiler that you get by default didn't do a super good job of finding those. The whole Google Cloud Functions assembly was all deployed using Google Cloud Build, which we open sourced the containers that you need to use to do that. So if you want to go and slurp those up, you can just point it at those YAML files, and it will do the right thing to make a Clojure script project deploy onto those functions. We had a lot of data transformation bugs that were happening in these functions, so we again started using Spec. But we enabled Orchestra, which is a tool you can use with Spec that when it instruments your code, it doesn't just check that your values that you flowed into your functions were correct. It also checks that the values that flowed out of your functions were correct, and it checks the fspecs. So that's the pair of inputs and outputs together. And we set it up so that it would actually throw an exception and retry let the request get retried on one of the instances that didn't have Orchestra turned on. And this offered us really, really verbose logs that described exactly what went wrong and how to reproduce the problem. We also switched from storing the majority of our data in Firebase, which was a kind of unstructured document store, into putting it all into Postgres. While I wouldn't go as far as saying that document stores are never the right answer, I would go as far as saying that Conway's law goes both ways. While when you have a organization, so Conway's law is that your organization is constrained to build software that follows communication patterns that are common in your business. So if you have two teams that never talk to each other, they'll never build a service that works with the other team. It won't happen. This also goes the other way, in my observation. If you make technology choices that constrain the ways that your services can talk to each other, those teams will also talk to each other in those ways. And document store databases, I find, often allow teams to not talk to each other about their data models. And so you end up with this disparity of what exactly is our data? Where do we put it? We don't know because we never argue about it. We haven't come to a consensus about it at all. So be aware there are risks when you choose to unstructure your data. We built our actual portal that we used onto Google App Engine, which was an excellent experience. If you are using a Clojure project, it is technically feasible to use their standard Google App Engine platform. It was a little beyond my Java interop foo. So we had to sacrifice built-in identity and automagical CDN for any Google-hosted cloud storage assets. But the flexible option allowed us to just package our thing as a Docker image, push it up, and that's all we really needed to do. It was, load balanced and had redundancy, gave us all the credentials we needed to talk to Postgres, as well as AutoML. We use as an alternative to using Google's built-in identity, we use Auth0 for authentication, which works pretty well with standard auth libraries. And if you want to take our little implementation of that from our thing. I posted a link to the repo. On the front end, we use CLJS with a little bit of reframe and material design to make it look kind of decent. Most of these things just worked really well. We use Luminous to kind of start up this whole project. Again, that worked really well. Keeping it turned on was an interesting problem with a group of people who weren't traditionally operations people. One thing I learned about operations was that operations is often about all the things you don't need to try. Because, you can go Google a problem and Stack Overflow is like, here are the 50 different things that can make that happen. And if you don't have the operations experience of trying 49 of those things before you finally got to the one that was actually useful, you don't have any context as to where to even begin. So we actually used a tool that Google had just integrated with their Google Cloud Shell so like when you first open up a Google Platform project, it pops up this little sidebar that gives you a tutorial of like, here's how you click on the Cloud Shell, here's how you start a compute engine instance, and it like actually highlights the buttons on the screen and gives you some descriptions. It turns out you can make those yourself too. They are just markdown files that have little selectors as to what buttons should be highlighted in the Google interface and some integration to make it so that it can spit shell scripts into your Google Cloud Console so that you can use your playbooks as a training tool to teach your operations people how to keep things turned on. But even with all of these things, the experience just doesn't come included. We had sent some of our co-founders to like Google Cloud Next and thought, oh, they can just go learn it. No, not so much. So be cautious with what you understand your co-founders to know. It's one fallacy I found myself making often was that my hope for my co-founders to become competent engineers or competent operations people would sometimes overwhelm my perception of what skills they actually had, which really sets them up for failure. So being aware of what you believe about your co-founders and what irrational biases you're going to have, and especially the ones you may project onto them, is really important for making accurate estimates of how hard it is going to be for your team to solve a problem. Google Stackdriver was the kind of the core of the operations work that I did. It does an excellent job of tying together logs from all of your services, exception handlings. It gives you an interface that you can go and mark these as acknowledged and all of those sorts of things. If you've done operations before, it's like PagerDuty, Logstash, and Datadog all rolled into one. For actually coming to consensus and like talking to each other, from the beginning of the company, we wanted to use something that wasn't Slack because, it runs out of room at 10,000 messages and it's Slack. So we actually used Keybase's group chat, which was excellent. I would totally recommend it. It started out kind of slow and janky, but by the end of Grownome, it had become just as robust as any Slack chat room I had ever used. And it also gave you this really interesting benefit that for every group you had, there was a encrypted folder that appeared on your file system that you could dump secrets into. And that kind of gave you this really robust tool for automatically revoking access to tokens and giving it to whoever they needed, and gave us a reasonable place to put sensitive information that, at most enterprises I've worked at, there really isn't that place. Like everybody's like, oh, just go look at the Dropbox folder. And you're like, oh, I'm not going to think about that. For doing our planning management, we had actually started using Pivotal Tracker, which was like massive overkill for a team of 4 people. We had also been using Keybase's free private Git servers. So they have this KBFS extension for Git that makes so you can get pushed to a Keybase repo, and it will GPG encrypt it magically for you and make so that all of your other people in that group can get to it. It turns out that's not super useful if you have a bunch of people who've never seen Git before, and you're like, okay, so let's do a pull request review, go run Git cherry pick, and now nothing works. So we decided that probably wasn't a good way to save money, and we decided to use GitHub instead. That was great. When we started to get more information about, we had talked to customers and done some interviews, and we tried different UIs and all these different things, we needed to store all that information about what we did somewhere. So we tried a thing called TiddlyWiki, which I had used on my local machine. It basically just stuffs everything into a HTML file that can update itself and saves it on your disk. It's pretty magical. They have a way that you can use it deployed on Google App Engine for multi-users. It didn't work super well. So we switched to using a platform called Notion.so, which is excellent. It's a wiki and CRM kind of thing, all rolled into one. Has a nice publish button that can make it so you can turn any wiki page into a public-facing thing. I put some links up to our wikis in case you're curious what a Notion.so notebook looks like. So at this point, it was January of this year. We had only grown to 5 customers. And I have a haiku about what happened. Infrastructure costs. One day your cloud credits will end. No more credits. Dead. We definitely died. It was from a variety of causes. Immediate cause was our cloud credits ended, and it was going to cost $300 to keep it turned on for 4 customers. Terrible idea. Long term, we didn't respond to negative feedback that the market gave us quickly enough. In systemic, we struggled to imagine worlds in which our perceptions of what our customers' problems were incorrect. So, in summary, remember these 3 points. 1, sell it now. Everyone, the whole team, go outside, talk to your customers. You need to sell it now. Your engineers too. 2, you need to know your own biases, what technology you know, what technology your company knows, the culture that your company has. These are all important variables that help you determine the direction that your company is going to end up eking forward in. And 3, your technology choices, they didn't actually have any impact on whether we were successful or not. You can choose the cleverest database or the cleverest programming language or the one you're most excited about. It all really doesn't matter. Choose the tools you like. Choose the ones you know well and the ones that the group of people that you're working on know well. No customer ever mentioned the little Lisp alien in our About page. I don't think any ever would. Your customer just wants to dish out a little bit of cash so that they can get some more value somewhere else in their process. So thank you.